Well, if you watched the first video, you saw what was hopefully a semi-entertaining explanation of why we bother studying statistics. So I won't spend a lot of time on this, but the bottom line is we need to be good consumers of statistical information, regardless of what our career path is. So the first thing we need to know is some vocabulary. There's a lot of vocabulary that is going to be thrown at you this course. I don't test on vocabulary, but you do need to understand these words just so you know what the book is saying and what I'm saying. So please try to be familiar with some of these things. You all should know what data is, and be aware that data doesn't have to be numbers, right? It can be any type of information. So it can be words, colors, anything like that. The population is the large group of things that you're studying, something that you want to know something about. And then the sample is that sub-collection of items from that population. So maybe you want to know something about all wolves in the wild, but you can't go out and study every wolf out there. So you collect a sample of wolves from Yellowstone and you study them. So that's population and sample. A census happens when you get data from every single item in your population. Very rare. And even a real census like the one that we take every 10 years in the United States isn't a true census because we don't actually get data from every single person. A parameter is any kind of numerical measurement that describes the population. So the mean, the standard deviation, those types of things, if it's based on the entire population, it's called a parameter. If it's based on just the sample, it's a statistic. And when we use parameters, we normally have Greek letters. And when we have statistics, we normally have symbols. So for instance, with parameters, we'll have Greek letters like mu for mean, or sigma for standard deviation, whereas in statistics we'll have x bar for mean and just s for standard deviation. Let's look at some examples. The Gallup Corporation collected a bunch of data from a little over 1,000 adults in the United States, and results showed that 66% of the respondents worried about identity theft. So in this case, what is our sample and what is our population? Well, hopefully you see that our sample is the 1,013 adults. The population, the thing that we're trying to understand something about, would most likely be all adults in the United States. So there's our population, there's our sample, and our objective is to use information from the sample to decide, kind of make guesses about what's happening in the population. Some of the key concepts when we're dealing with statistics, we have kind of 3 steps. We want to prepare, analyze, and conclude. What does that mean? Well, prepare means what's the goal of the study? What are the questions you want to answer? Are you trying to figure out what's the average likelihood that an adult will get cancer? Those types of things. Or what's the likelihood that a Republican will vote a certain way or an independent will vote a certain way? So those would be the questions you would study. Then you prepare by getting data and making sure that you ask yourselves, is the source of the data objective or is it biased? Did you sample in good ways? Or is your sampling technique possibly flawed? There are certain types of sampling methods that have problems. Voluntary response, i.e. surveys and things like that, have a built-in bias. So just know that anytime data is collected through surveys, there is a built-in bias because people who are likely to participate in a survey are statistically different from people who are not likely to participate. So the results you get are always biased. But unfortunately, it's kind of something we have to live with because a lot of data is collected through surveys. Okay, once you have the data, you should always analyze it. We'll learn in later chapters some more robust ways of analyzing the data, but we'll start off with basic things like how to describe them visually. And then you make some sort of conclusion. And you're looking for some sort of statistical significance of your data. The key here is if we get a result that is very unlikely to occur by pure chance, that tells us that something else is happening, and that means we get a statistically significant result. However, there's a big difference between statistical significance and practical significance. Practical significance kind of relies on some common sense, which we know isn't as common as it used to be. But here's an example. So let's say you had 40 people. They all had an average loss of 4.6 pounds after 1 year on certain diet. You use some statistical analyses. The data comes back and it tells you this is a statistically significant result, which means the result of 4.6 pounds you get of a weight loss is too uncommon for you to think that it just happened by pure chance. So statistically, it seems to imply that the weight loss program is in fact effective. But is 4.6 pounds really practically significant, right? It's statistically significant, but does it really matter in a kind of quote-unquote who cares situation? And no, 4.6 pounds is not a lot of weight to lose in an entire year. So another thing that we want to discuss in this chapter are potential pitfalls or misleading conclusions that we can do with our data. Just because one variable relates to another does not mean that one variable causes another. So two things can be linked, but that doesn't mean one causes. So something you'll hear over and over again, correlation does not imply causality. In fact, there's a very strong correlation between ice cream sales and homicide rates. Every time ice cream sales go up, homicide rates also go up. And every time ice cream sales go down, homicide rates also go down. So, if you didn't know any better, you would think one was causing the other, that when people buy more ice cream, all of a sudden they go out and kill people. And that's not the case at all. What's happening is there's what's called a confounding variable. Another influence that's in there that's not within your model, and it happens to be the weather. Every time it gets hotter, people buy more ice cream, but they also get more agitated and they tend to kill each other more. So that's an example of correlation not implying causality. Other potential problems is if you have a really small sample, you're going to get completely misleading results. Another big problem is if you just collect your data poorly. So if you have misleading or loaded questions. If you look at these two questions, should the president have the line item veto to eliminate waste versus should the president have the line item veto or not, you can see how the first one is kind of a leading question because you're saying to eliminate waste. Well, everybody wants to eliminate waste, so that's a bad question. Another one is just the order of questions. If you are asking people to kind of rate things and you put them in an order, they have a tendency to choose the first one if they kind of have no opinion. The other pitfall, as I discussed earlier, is the non-response pitfall, i.e. just anytime you survey people, you introduce bias because, as it says here, people who don't do surveys are statistically different from those who do. So you're going to get a kind of a skewed picture of the population. Missing data is always a problem. If people drop out of the study or you just missed an entire type of person. Precise numbers. Just because a number has a lot of decimal places doesn't mean it's accurate. So if they claim the average is 42.72, that doesn't mean that it's 100% accurate just because it has 2 decimal places. Like if they said it was 43, you'd think, oh, well, they rounded that up, it's not accurate. But that really has no bearing whatsoever. One last one are percentages can be very misleading. This quote from Continental Airlines in a recent ad where they've already improved 100% in the last 6 months with respect to lost baggage. A lot of people will misinterpret that and think that they're not losing baggage at all anymore, and that's not the case. Let's say on an average month they used to lose 20% of everybody's bags. If they improve by 100%, then that just means that they now only lose 10% of your bags. Right? So they're not perfect. Okay, in summary, you need to understand the vocabulary, the importance of statistics, the 3 steps involved in conducting statistical analysis, which is prepare, think about your question, analyze, figure out what the data tells you, make some logical conclusions, knowing statistical versus practical significance, understanding the pitfalls and misleading results, and last but not least, remember that correlation does not equal causation. And that's everything from this section.